Year 6, Lesson 3, Extensive Exercise, Question 1. So the diagram below is made of a number of equilateral triangles. How many equilateral triangles of any size can be found in the diagram? So here we've got to count equilateral triangles in this kind of equilateral triangle pattern. Now, the way we do this is we start by classifying those equilateral triangles by size. So the first triangle that I'm looking for is what I call a 1 by 1 equilateral triangle. It's just an equilateral triangle with one triangle along the base layer. And we can count these up. We can count that there are 25 in total. Now, the next size triangle we're going to look for is the next smallest equilateral triangle, which is formed by 2 triangles in that base layer. Or you could imagine each side of the equilateral triangle consists of 2 equilateral triangles. And it's a little bit more tricky to count these, but you can kind of see that the first one fits in there, and you can fit in 2, 3, 4 along that bottom layer. And we move it up, and we can find 5, 6, 7. Then we've got another 8, 9 in the next layer, and one final 10th at the top there. So far I found 10, but we must also consider any upside down variations of this equilateral triangle. For example, we can find one I've just marked there, you can see carefully. That makes 1. And if we go down a layer, we can find another 2. That's 2, 3. And then if we go down a layer, we can't fit any more in. So I've got 10 plus 3, so that makes 13 in total. Next, we are looking for the next size equilateral triangle, which is the one formed by 3 triangles along that base layer. So if we start on the bottom layer of our big triangle, we can find 1, 2, 3, and we move it up, 4, 5, and then we get 1 at the top. That makes 6. Then we look for some upside down ones. So this is a 3 triangle along that base layer. So the first one we're going to find would be here, and that can't fit in our diagram. So we've just got 6 for that size triangle. So then we can move on to a triangle with 4 equilateral triangles along that base layer. And we can see that we're going to fit in 1 along the bottom there, and another one to the right. That makes 2, plus 1 if we slide it up to the next layer. So we've got 3 of those ones. And of course, we can't find any upside down. Right, almost there. We now need to consider the biggest possible triangle. So that's the triangles with 5 equilateral triangles in the base layer. There's just one of those. It's the full triangle. Okay, so to answer this question, we just need to add these all up. 1 plus 3 makes 4, plus 6 makes 10, plus 13 makes 23, plus 25 makes 48 triangles in total.